Hey, good morning, everybody. It's Troy. Just wanted to bring you kind of what a normal day in the life of Troy is. Wanted to show you guys my job and that kind of stuff. And I figured, what the heck, at least I can use some of this stuff to help train my guys. So, um, I guess yesterday what I was doing was going over a TV transmitter for KTTW in Pierre, South Dakota. And it's got a bad reflected power um, reading on it, and I wasn't sure where it was coming from. So um, this video is a little bit about troubleshooting that, and then it'll have a whole lot of other information in it, basically about what I do for a living and what kind of stuff I get to play with. I think towards the end of the video I even got into the FM transmitters in the back of the room and that stuff. So this is just one out of the 40 or 50 sites that I go to in a month's time. So as we go along, I think what I'm going to do is start basically making training videos for my guys. But yeah, I figured I'll bring you along for the ride and show you what's behind the curtain as far as your AM, FM, and TV stations, how we make it work and how all of those systems go together, because we've got literally hundreds of pieces of equipment in line with your audio at any given point in time. So there's a lot of stuff, and I'm going to try to take what can be a very complicated field and simplify it as much as I can for you. I know my explanations are going to sound a little off. Don't worry. Like I said, I don't like to remember formulas and stuff like that. I can do that stuff, but I don't. I think it's way too easy to make a semi-simple everyday thing be really, really complicated if you want to. And I'm going to try to make it as simple as possible for you. So please forgive the explanations, but we'll keep rolling and see if we can make some engineers out there. So, yeah, here is a normal day in the life of Troy. Okay, kids, we're back. As you can see, I had to take part of the transmitter out. That's this guy sitting on the floor. Inside this unit, this is an amplifier section of a transmitter. You'll see we've got two slots here, right? And these are the amplifier modules that go in there. They're just boards with a big heat sink on them, but they're linearized amplifiers, which means that their power curve is pretty straight, right? I'll explain linear amplifiers and analog amplifiers someday, but normally there's an amplification curve to every amplifier, and the more linear we get it, the better reproduction we have of the original signal. So when we're modulating digital carriers, right, we can't have a lot of room for error, because the computer only knows what voltages it's supposed to see. If it doesn't come in at the correct voltage or the correct amplitude, it can't decode them. Well, this one, being that we have multiple amplifiers, we've got a combiner system in the back of it that uses mutual inductance and some capacitive coupling and a couple other different methods. But on this one, we've got a combiner, and in every case in RF we have to go 50 ohms. That's just the magic number that works out right for everything. So right now what I'm going to do is we are going to take this apart and start digging into that combiner system to see if our reject load went bad. If it does, what happens is the impedance of the entire system goes bad and our amplifiers don't see the proper impedance. They get finicky and start shutting down on me. So that's where we're going to go. I will be back in just a few minutes and we will have the cover off and take a peek inside this bad boy. Okie dokie, we're back and we have all of the screws out, so we're going to lift the case and voila, we have a really dirty box. You can see there's a lot of bugs and stuff through here. Those are all looking good yet. No, normally on these capacitors here, these guys, you'll see the tops of them get bubbled out or cracked if they go bad. That's probably just part of a control circuit for the fans more than anything. This is our combiner right here. We have our main output going out, and we'll probably have to tear into this guy and see if that reject load resistor is bad. It'll be a 50 ohm block resistor more than likely inside here. But we'll dig a little bit deeper. This one right here is actually a splitter. So we bring our main signal in way down here in the back corner. It's coming in from the exciter portion of the transmitter. Comes into that cable. Runs all the way around the transmitter up here to our splitter. The splitter splits it off and then sends it down here into the input card for our two amplifier modules where they plug in. And then these big connectors inside here, that big silver connector right there, those are the outputs to it. Right, each module has an output that feeds into this combiner, and then using the combiner we put those signals together, add them together basically with a little bit of loss. The loss is just pretty much the imbalance between the two. So if one's running at 500 watts, the other one better run at 500 watts. Otherwise it's off balance and the reject load will kind of get make up the difference to balance them out. So that's what happens in this box. We're gonna tear into that combiner a little bit and see if we can get a little bit further down into it and see where our combined system went bad. All right, well that was fun to get out of there. Had to take the entire mounting plate off of there to get it out. And this is what our combiner looks like. If you notice, we've got one input coming in with a full trace that comes all the way through, and the second input that comes in, and he's just got a partial trace. Now what they do is, it's a dual-sided board, I believe, and they have traces that go underneath the board on the bottom side, and they basically run the trace along with this trace for the secondary input, right? That way they both ride opposite sides of this board. They get combined together, and this point right here coming out to this resistor. This is a 50 ohm resistor. As you can see, it looks like somebody has resoldered it, or they didn't do a very good job at the factory. But I did check that resistor, and it is 50 ohms, so we do have a good reject load. From there on, we just have to look at this cable then all the way out to the rear connector of the transmitter to make sure that we don't have a bad cable or anything like that. But this transmitter keeps showing me this phantom reflected power, and I know it shouldn't be there because I used a network analyzer to sweep that big black transmission line, this guy right here, all the way up, right? That guy there, I swept him using my analyzer, which, if you guys haven't seen one, this is my pride and joy. That right there is a used pickup truck. $15,000 of fun. But with this guy, I can sweep lines and make sure that the impedance and everything is tuned just right so that we're hitting resonance at the input of the antenna. And that would be way up there. I believe that you can kind of see them. It'd be that top antenna that's sticking off the side of the tower there. The one with all the long standoffs on it. That guy is my TV antenna. And we'll keep working. Hopefully I can figure this guy out and see what cable's wrong or what in the mix is bad. If not, we've just got a bad processor inside the controller for the transmitter, and it might just be a little dumb on us. So we'll keep hunting, and hopefully we'll find her. If not, I'll keep it on the air with a couple hundred watts, and we'll call her good until I can figure out a contingency program. So keeping rocking. I'm going to put this thing back together, get it slid all back together in the rack, and we'll come back after that and pick her back up again, maybe do some more troubleshooting. Okay, we're back, and as you can see, I got it all put back together. Everything's hooked back up, and I took the shop vac through this thing and cleaned it up really good because, well, if your transmitter can't breathe and it can't keep itself cool, it's not going to be happy. A clean transmitter is a happy transmitter. So I'm going to put it back in the rack. We're going to hook it all back up, and then we're going to start working on the controller, because as of right now, I can't find anything mechanically wrong with the system. I've got a good mask filter. That's this guy right here. That just basically makes sure that we filter out any of the RF that's coming out of this transmitter and make sure that it meets the FCC mask that we're supposed to hit. Basically what we do there is filter out all the noise so that we're not interfering with anybody else in our neighborhood. So we'll get the rest of this all put back together, get her wired back together, and maybe clean up some of this stuff because it looks like a mess. But like I said, these are the things I run into as a broadcast engineer, as a contract engineer, because this isn't necessarily my site. I just am hired to fix it. So normally I'm down on that end working on the big FM transmitters. These guys are my normal cup of tea. 20,000 watt FM transmitter here, and its older brother, same 20,000 watt, just a little bit different design. But as you can see, they changed the colors on them, but didn't change a whole lot else. The only other things we did was our IPA section, our intermediate power amplifier. In this old school guy, we have a power supply that's all transformers, so it's all, you know, basically mechanical design, which is why this one's still running at full power. And this guy has a solid state IPA. It takes a linear 48 volt power supply, and if that doesn't work, then the transmitter doesn't work. So just like cars, you know how they add a bunch of computer controls to it, it ends up screwing it up. And that is exactly what I'm looking at right here. Is I have a fully functional transmitter, but the computer isn't seeing something right inside there, and because of that, it won't let it run. So it's a little frustrating, but these are the things you have to deal with. Remember, hardware is only half of the solution. If we've got a working amplifier and a working transmission system, that's great and all, but if the computers don't like it, then we're dead in the water. So let me get these guys back on the air. They've been off for about 2 hours now while I've been messing around. And I am sure there's a lot of people at home that would love to see Fox right now. So let me get moving and get them back up real quick, and I will be back in a little bit. Well, another little stop is I decided to take the cover off the top of each amplifier. If you look in here, you'll notice that there's a lot of dust, debris all over this stuff. The more dust you get inside these units, the worse it is for heat dissipation. We have to make sure this stuff keeps cool, otherwise it burns itself out, which is why we have that huge heat sink along the bottom here, right, on both of these. And you can see bugs and stuff get kind of caught up in there and basically make it so this darn thing can't keep itself cool. I definitely want to check these guys. You notice we do get a little bit dirty at this job, even though it's mainly all dirt, but I am going to take the shop vac through this guy and maybe check out some of these capacitors here. I'm going to check these two guys out, and then I want to check this guy in the back, that B. That guy's going to be the same as in the other, in the combiner of the transmitter there. I did get it racked up and put back in already. That is a reject here for these two amplifiers. We've got two separate amplifiers. These two white boxes are the amplifier modules, or the amplifier chips. It's a good one. So we'll do a little bit of checking out of both of these guys, clean them out, make sure everything's working good, and then we'll keep moving with the troubleshooting. Hopefully we can find our problem somewhere along the way. If it's not these capacitors or that combiner reject load there, I'm not exactly sure what we're going to find. I'm still banking on it being a software problem. I think the controller got bit by lightning one too many times. So we are going to keep rocking away, and hopefully we can get her. Okay, well that didn't take long. Took the shop vac in here, And if you can see this capacitor right there, you'll notice that he's got kind of a rounded top to him. That right there is the power, the filter for the power coming in for my two amplifiers. And both of them are looking a little bit rough, like they've been stressed one too many times. And granted, this transmitter's been on the air for almost 10 years. So this thing definitely has some age to it. Those are definitely issues, so we're going to have to probably get replacement modules. As you can see, all of this stuff in the middle, it's all wave soldered, it's all put down on the board. They make it almost impossible for you to fix the stuff. So we can hopefully just get a whole new module and put it back in and run it. Which is another reason why I don't like these new solid-state transmitters. Like I said, I'm usually down there working on them big ones. Well, with these little ones, I can't necessarily fix it component level like I'm used to. Normally, if I have a bad problem or a problem in one of those FM transmitters, the components and everything are so much bigger because of the frequency that there's not a whole lot of this kind of stuff, just in the controllers mainly, and even those are older to where you can still solder on them. So it's a little bit different nowadays, but you know, this is my day. So we're gonna keep cracking. Okay, so now we got the second amplifier module open, and you can see on this one the difference in those caps. See, this one's nice and flat, and that one's got a nice rounded edge to it, right? Most of my job is going to be looking. We just look around to see what don't look right. 9 out of 10 times on bigger transmitters especially. These little guys, yeah, it's a lot harder to pick out. But most of the time, when you have a 20,000 watt transmitter decide to eat itself, it definitely shows you. You can see the black marks, you can see the burnt pieces, you can find all the bad stuff. On these little boards, a lot of this low voltage stuff can go bad, and then all of a sudden your transmitter stops running, and you're sitting here like I am right now, where I'm not exactly sure what the heck's going on, but we're gonna find it. Keep looking. Okay, so I checked both of these out. Yes, we do have these two capacitors are pretty well leaking, which is giving us a lot of issues with our power supplies. I think that might be most of the cause of today's issues as to why it won't stay on the air and stay stable. We are going to keep cracking, but I am going to get another module ordered and roll from there. Alright kids, we're back up and running. We got Maury on, everybody's happy. It's still 79 watts is all we can push out of this thing. We should be closer to about 200, 250. But it's on the air and making noise for now. I've got to order several replacement PA modules for this thing. And then when I come back, we're gonna worry about the controller software and updating the controller on that trip. I don't want to change too much now while I've got it stable and still running. At least when I come back with the replacement parts, I can mess it up and it can go off the air. But for right now, I just want to keep it as stable as possible, and hopefully it will remain that way until I get back here with the replacement parts. Just doing a little weather check. You got to do that out here in the Great Plains from time to time, because especially this time of year, weather can sneak up on you. So, yeah, looking decent. And there's my girl, my favorite little toy. I'll do some more flying around today, maybe. I don't know. The wind's a little bit rough, but I think she can handle her. She'll go all the way up to a 30-mile-an-hour wind, but yeah, maybe see the sights around here, and we can get back to that. So on this end of the building, we got 1, 2, 3, and a little itty bitty relay point. So there's three TV stations on this tower, and then we've got 2 full power FMs. And to tell you the truth, I installed both of these transmitters probably 8 to 10 years ago when I was working for my old company. And I did the frequency change on both of these units because they were both bought used. These cabinets right here, this one and this one, these are just the power supplies to run the final tube. Let me see if I can find you a tube to show you real quick. Yeah, I got one in this box here. And here we've got an electron tube. It's a old school style amplifier. And be very careful with them, because if you're going to get them replaced, these suckers are about $5,000 a piece. Don't want to touch it with your skin too much, which is why we keep it in a bag. I'm not sure exactly what elements they use. I think there's some gallium in there, a lot of silver coating on them to keep them conductive. But you'll see on this tube, this is a tetrode tube, right? It's a 4CX 20,000A. So the 20,000, I don't know, it's an approximate power rating, but they use them in so many different size transmitters that it's about a 20,000 watt tube. So we usually have to come in with about 400 watts on them just to get them to excite enough to turn on. But you'll see we've got one ring here and another ring on the inside and the bottom. Those are the filament rings. Inside here in the ceramic tube, we've got basically a light bulb. It's a tungsten core screen, and it glows red hot. It heats up our grid, which is this ring right here. So this grid ring, we come in as a negative, electrons coming in with our signal. They jump off of this screen, the control grid screen. This is a control screen right here. So we got our grid, our screen, and then the very top up here is the anode. This screen runs at about 1500 volts. We can run it anywhere from 0 to 1500 volts. Normally on this transmitter style, we don't go much over 900 volts on that screen. Usually that's the max on that transmitter. This anode up here, this is where all the magic happens, and you can tell by the amount of cooling, right? These fins are actually not for anything but to keep this section of the tube from overheating and melting itself. When you're running 20,000 watts of power, you can vaporize copper. So that is one of them things that you don't play around with, and you only get to mess up once on it because, like I said, this anode is sitting at 10,000 volts a lot of times. So if we come back and look at the FM transmitter right now, this one usually runs right at about 7,600 volts or 8,000 volts. And it's usually at 3.3 amps. Now, right now, it's a little sick because we don't have an IPA working. I'm running all of my power off the exciter. This little box right here, the exciter, what he does is he actually brings in the audio and creates the carrier frequency that our transmitter runs off of. He does all the encoding, so it brings in the audio, makes the carrier frequency whatever it's supposed to be. This one, I believe, is 95.3 on the FM dial. It takes that audio, puts it on that 95.3 megahertz signal, and then ships it out at usually about 5 to 10 watts. Right now I'm running it hot so that it will actually excite the tube. The final tube's in the back of the transmitter, and since this isn't mine, I'm not going to open it up. But normally that would look a lot cleaner and everything would be a lot better. Plus we would see about 350 to 400 watts coming out of our intermediate power amplifier before it goes to the final tube. So we come into the grid at 450 watts, right? It's all negative biased. It sees this screen that's a positive at 1,000 volts, and it says, hey, we want to come off of here and flip up into here. This is basically just here to help strip electrons off, right? So we start stripping electrons off of our main grid with our screen, and as they're coming up, they see this 10,000 volt positive and go, whoa, we want to go there. So instead of ending up at the screen and leaving the tube, it's basically just coaxing the electrons off the grid. That's the easiest way I can explain it. I don't want to get into too much math and crap like that because it shouldn't be that complicated. But that's how our FM transmitter, or this style of FM transmitter, works. Most of the time nowadays we're getting into solid state, so it's cabinet after cabinet of amplifier after amplifier, and they go through a combiner system like in them little TV transmitters. It's just an overgrown version of that. Now this site was especially fun to install because on the back side here you'll see these Shively Lab filters. This is actually a combiner system to where we can run both of those transmitters. See the copper pipe going across the back? And then it comes down here and it goes in right there. Right? Same with this transmitter here. We got our low pass filter. We go through a couple of power samples. These are basically just measuring the power output of the transmitter for the controller. And then these are an external watt meter that we can see what kind of power we're putting out. So this one is running about 19,000 watts. So we got plenty of power going out of that one. The other transmitter, we're just sitting at 1 kilowatt. It's a 2,500 watt slug in that power port. Or is it? Nope, it's a 25 kilowatt slug, so we're putting out about 10,000 watts out of this one. Right? So we go into these filters, and basically what the filter does is it notches out the other transmitter. What'll happen is when we're transmitting, transmit antenna is identical to a receive antenna. There's no difference in them. They're just basically, it's however long your antenna is, we compute that to the wavelength, and that's what frequency it's tuned for, right? But here what we do is we come out of these two filters, we go through some trombones so that we can get the exact distances correct to make sure that we're completely resonant when we get up there. So we combine the two signals onto one transmission line, and then this guy goes out the building, goes up to the tower, and we have two FMs coming out of the same antenna. It's a wideband antenna, which means that it's basically tuned flat across the FM band, or across whatever section of the FM band we want to use. These two transmitters are on opposite ends, so it's pretty well flat all the way through. So beyond that, we're gonna keep moseying on, and I think I am gonna kick out of here for the day. Hopefully come back a little bit later. Talk to you guys later.